We will go through the key sites of our unit. It is a unique opportunity that ordinary visitors do not have. This is the so-called brain, the brain center of the entire power unit. We are going along one of the routes of the senior operator of the reactor department. This is the panel where the very buttons for the emergency shutdown of the reactor are located. This is where fresh fuel is loaded into the drum to go into the reactor. Alright, let's go to the turbine hall. Good afternoon, everyone. Welcome to the 4th unit of the Beloyarsk NPP. My name is Andrei Smelov, I am the plant shift supervisor. Today, I will take you on a virtual tour of the key sites of the Beloyarsk NPP Unit 4. We will walk through the key sites of our unit. The central hall, where the reactor is located. The turbine hall, where the turbine generator is located. And the control unit, from which operators control all the equipment and monitor the state of the reactor. The admission procedure is not limited simply to changing clothes, it is also necessary to obtain dosimetric control equipment. We fix it correctly and move on. We are on our way to the central hall, the heart of the nuclear plant, where the reactor itself is located. This is the very place that you all probably recognize from photos. Some people call it the octopus. These are sodium pipelines on the reactor's cap. The reactor itself is 16 meters below. The central hall is the heart of the atomic unit. The reactor is right below us, under the biological shield. Secondary sodium flows through the pipelines, which you see. We see a transfer box, a washing box, where nuclear fuel, both fresh and spent, is transported. This is the famous orange cap of the reactor, under which are the controls and protection of the reactor. In addition to the reactor, the central hall contains secondary circuit equipment. For example, the main circulation pumps. You can see their electric motors, purification systems, secondary sodium traps and numerous auxiliary pipelines. The height of the central hall is 75 meters. It is able to withstand a crash of a passenger plane, a hurricane, and a 7.0 earthquake. Secondary sodium flows through pipelines with a diameter of 800 millimeters. This sodium is not active. It receives heat from the sodium in the primary circuit through intermediate heat exchangers, which are located inside the reactor vessel itself. All equipment is made in an integral layout. That is, everything that interacts with active sodium of the primary circuit is in a single housing and is enclosed in an additional safety housing. This approach eliminates the interaction of active sodium with the environment and equipment. This is the so-called three-circuit scheme aimed at ensuring safety. The excess pressure in our reactor is only half an atmosphere, which is significantly lower than the pressure in thermal reactors. This is another safety advantage. As you can see, there is no one except us in the central hall. Usually, operators walk around here 3 times in one 8-hour shift to supervise the equipment operation. The constant presence of personnel is not required here. The equipment is controlled automatically by the automatic control system. We are going along one of the routes of the senior operator of the reactor department. This is a unique opportunity that ordinary NPP visitors do not have. The best observation deck in is the central hall. The most interesting thing is to go through the body control installation and then go to the exit. We are at the reactor control room, the so-called brain center of the entire power unit. Here, the personnel responsible for the operation of the equipment, which is divided into zones, reactor, steam generator, and turbine generator, sit. All personnel have special education, a license for which they pass the exam. They have climbed all stages of the career ladder, starting from junior operators. Leading engineers, shift supervisors, and the station shift supervisor sit here. We go to one of the most important panels, the panel where the buttons for the emergency shutdown of the reactor, made famous thanks to the HBO show, are located. There are two of them, they are sealed, they are behind protective covers and there is no free access to them. This is what the station shift supervisor's workplace looks like. As you can see, he has a complete overview of all operators, he sees all monitors and can assess situation at the unit from his place. For convenience, there is a shared screen, which schematically shows all equipment and its state. Each operator has their own workstation from which they control the processes and equipment. The station shift supervisor has access to all equipment, and operators have access to the equipment assigned to them. In addition to the workstation, there are secondary work panels in case of a control system failure. It is possible to shut down the reactor and control all equipment in general using these panels. We are in front of the turbine hall entrance. It is very noisy, and earplugs are required. All equipment of the third circuit, the steam water circuit, is located in a separate building, in the turbine hall. There are just 4 employees required for the huge machine room. The feed water consumption is 3,000 tons per hour. The water enters the steam generator, and then turns into steam, which is fed to the turbine, where electricity is generated, 882 electric megawatts. The most spectacular place of the turbine hall is plus 15 meters, where the upper part of the turbine generator and steam supply pipelines are located. As you can see, there are 2 huge cranes for the assembly of heavy equipment. The turbine generator rotor is 42 meters long. Turbine generator comprises 3 low-pressure cylinders and high-pressure cylinder. In addition to the turbines, there is also generator and generator excitation system. This generator generates 882 megawatts of electricity, which is sufficient for a city like Yekaterinburg. We are at the platform of the high-pressure cylinder. There are also blocks of control valves, stop valves, which shut off the steam supply to the turbine generator in emergency modes. Here is the high-pressure cylinder, which receives about 500,000 tons of steam about 500 degrees Celsius. This concludes our short tour. I hope it was interesting for everyone. All the best.